Is that clear? Which symbol? It's actually the symbol for specifying the standard state. So if you simply write delta H, it is enthalpy change, but it is not measured under standard condition. What is the standard condition? 1 bar pressure. That is the standard state. What is the state of a specified temperature at 1 bar pressure? That is what important. The name is like some Greek letters, but not theta, but somewhat related to that. Okay, so we are moving to the next point, standard enthalpy of formation. So it's a very, very important point. Standard, and so you can write the main heading, standard enthalpy of formation. As the word indicates, it is standard, that is under standard condition, and it is enthalpy, that is the... Sorry?
Are you sharing a screen?
Yes.
I don't think I cannot see it.
Okay, I'll just reshare it. Okay, I hope it is visible now.
Yes, ma'am.
So standard enthalpy of formation, you can represent in the bracket, you can write the symbol delta H and standard sign, and F stands for formation. So fusion, we used to write FUS, but if it's simply F, that is standard enthalpy of formation. So for the phase transformation, we were writing 3 letters like that. Fusion is FUS, vaporization mean VAP, and for sublimation you write SUB. But for formation, we are simply writing F. It's one of very important enthalpy changes which we are discussing. So as the name indicates, it is related to the formation. But what is to be noted is, it is the formation of 1 mole of a compound. So as I specified, it is formation of 1 mole. You're preparing 1 mole of a compound. It could be H2O, it could be carbon dioxide, it could be calcium carbonate, whatever it is, from its elements in their stable states is called standard or molar enthalpy of formation. Standard or molar enthalpy of formation, because you have to prepare 1 mole of any compound from its elements under the standard state. Say example, if you are looking into this equation, H2 plus half O2 giving H2O. But if we know that the balanced equation can be written like this, 2H2 plus O2 giving 2H2O. This is technically correct. This is a balanced equation. But this is not standard enthalpy of reaction because you're preparing 2 moles of water here. So it is the formation of 1 mole of any compound from its elements under the state. So elements should be like hydrogen in the gaseous state and oxygen in the gaseous state, because under standard condition, hydrogen and oxygen are diatomic molecule in the gaseous state. So you cannot take O2 in liquid or solid state, hydrogen in liquid or solid state to write the standard enthalpy of formation of water. So one point to be noted, it is formation of 1 mole of a substance, and secondly you can say it should be from its elements. Say I can prepare H2O from this reaction, HCl plus NaOH, a neutralization happens, so you will be getting NaCl plus H2O. So here also H2O is produced, right? But that is not enthalpy of formation, because here the formation of water is not from its elements. It is by the reaction of HCl and NaOH, 2 different compounds are reacting. So this is also not enthalpy of formation. So it should be formation of 1 mole. Here you are getting 1 mole, but the problem is that the reacting materials are 2 different compounds, not the elements of H2O. So the correct definition for or equation for enthalpy of formation of H2O is H2 plus half O2 giving H2O liquid. That state, if you are not specifying H2 in the gaseous or oxygen in the gaseous or H2 in the liquid state, your answer is incomplete, because as per the definition, It should be in the standard state, so you need to specify the state of all these elements and the product, the H2O liquid. So I'll just repeat, standard enthalpy of formation, it is the enthalpy change during the formation of 1 mole of a compound from its elements under the standard state or condition. And you should know what is its representation symbol. And you can write one example over here, hydrogen, and one more is given here for methane gas. You can see for carbon, they have written graphite and also comma solid in the along with the carbon. We used to write C plus 2H2 giving CH4. But they have also specified that the source of carbon is graphite, because we know we have different allotropes of carbon. So you need to specify which one you are using. So with graphite, if you are taking as a carbon in solid state, this is the standard enthalpy of formation. If you are using some other form of carbon, then this value will not be matching with that. So examples, phosphorus, you might have heard about phosphorus. There is red phosphorus, yellow phosphorus. So you need to write that like this along with the element. So then only it will be correct. So under standard pressure condition, what is the state of that particular element in the specified temperature? That should be specified. So we cannot simply write carbon as a solid, because carbon can be in different form, because allotropism is there with the carbon. You don't have to by heart any values. Okay, it will be given if there is any numerical. This is just for your understanding. They have given what is it.
Ma'am.
Yes.
Ma'am, in the example, the second line, could you explain that?
This one? Yes, Siddharth? What I highlighted?
No, ma'am. The standard enthalpy of formation of H. Sorry. Yeah, oh, okay, never mind, ma'am.
That is a representation symbol. Denoted by?
I got confused between H2O and...
No.
Yeah.
Like this. Okay. Is the definition clear? What is the meaning? Like it's the formation of 1 mole from its elements in the standard state. It is also known as molar enthalpy of formation, standard or molar enthalpy of formation, because you are preparing 1 mole of a compound. And you may write 1 or 2 example. Now let's discuss different scenario. Can I change the slide? Done? Have you all finished writing?
Ma'am, why is it kJ per mole?
Kilojoule per mole energy. Because you're dealing with 1 mole and kilojoule is the energy, unit of energy, right?
Yes, sir.
So usually energy is kilojoule and per mole because you're preparing 1 mole.
Okay.
So here one more example, here you can see calcium oxide and carbon dioxide giving calcium carbonate, and it is written enthalpy of reaction, not the enthalpy of formation. Again, as I said, here the 2 different reactants are reacting to give you calcium carbonate. So it is not enthalpy of formation. So how can you write the enthalpy of formation for calcium carbonate? Calcium, what is the state of calcium in the normal solid, plus carbon, you have to write graphite. Graphite is a reactive form of carbon. Diamond is non-reactive form. So, and the other ones which you know, like different sources like that are impure, you need to take the purest form. So that is what graphite we are opting. So graphite and solid, that you need to specify, plus how many oxygen?
3.
But you can't write 3O because oxygen is O2. So how much oxygen molecule you need? 3 by 2. 3 by 2 because it's just one molecule, you can't take more. 3 by 2 O2 gas is giving CaCO3 solid. This is what the enthalpy of formation for calcium carbonate. That depends. You cannot always say that. From which kind of material you are the reaction is taking place. Calcium carbonate can be prepared in different way. So this is enthalpy of reaction for calcium carbonate, which can be in a different way. This is one way of preparing calcium carbonate in a chemical reaction. But enthalpy of formation is only one way. You cannot have more than one way for enthalpy of formation. So in multiple choice MCQs, like they will be given for a different option. You may have to choose incorrect or sometimes the correct equation for the enthalpy of formation. In competitive exams, you will find enthalpy questions like that. 4 options will be given. You may have to choose which is correct or incorrect from the actual equations. So maybe 4 will be given, 1 will not be an enthalpy of formation. You may have to pick it up. Is that clear? Okay. If you look in the next scenario, in the next scenario is like I am preparing HBr, hydrogen bromide, from hydrogen gas and bromine as a liquid, H2 gas plus Br2 liquid giving 2HBr gas. And this is also enthalpy of reaction, not enthalpy of formation, just because it is 2 moles. Rest are same, H2 and Br2, okay. But here you are preparing 2 HBr, so that is also considered as enthalpy of reaction, not the enthalpy of formation. So you will find a relation over here. The enthalpy of formation, or you can see in this case enthalpy of reaction Okay, so here what you can see is like enthalpy of reaction is 2 times enthalpy of formation because you're preparing 2 HBr. So that is enthalpy of reaction and this is actual equation for enthalpy of formation. So some cases you can relate that enthalpy of reactions are related to enthalpy of formation in a multiples, symbol numeric, whole number multiples of it. This is enthalpy of reaction, which is related to enthalpy of formation. Like same thing you can get it in the case of H2O also, like H2, 2H2 plus O2 giving 2H2O. This is not enthalpy of formation because it is 2 molecules of water is prepared. Actual equation is H2 plus half O2 giving H2O. So if you multiply the Ender equation of enthalpy of formation with 2, you will get the above equation. So that means this is enthalpy of formation of water, and this will be equal to 2 into enthalpy of formation of H2O. Usually to specify what is the compound, we used to write that compound in the bracket. That means it is enthalpy of formation of H2O. So this is applicable only when the actual equation of formation and the enthalpy of reactions are in direct multiples, whole number multiples. This equation, if you multiply it with 2, then only you are getting the other one. So it is enthalpy of formation and enthalpy of reactions are related. Any doubt in the enthalpy of formation which we discussed? So I'll just repeat what we discussed so far in enthalpy of formation. It's very, very important because other enthalpies are related, the many calculations are related to it. Enthalpy of formation means formation of 1 mole of a compound from its element in the standard state. And it can be like denoted by delta F, delta H, F, that is F is subscript showing the like for formation. And as I said, the reference, it should be like specifying the what is the state. Like you need to specify which allotrope of if there is an allotropes of possible for a particular element, then it should be like you need to specify which one and also the state. And then we just move into different cases where we found products are formed, the compounds are formed, but is not considered as an enthalpy of formation because they are prepared from different reagents, not elements. That is the first point. And then secondly, you can see when 2 moles are prepared, then that is also not considered as enthalpy of formation because as per the definition, it is for the preparation of 1 mole. Okay. So next side heading, thermochemical equations. Thermochemical equations. Thermochemical equations is nothing but what we have just written, a balanced chemical equation together with the delta H enthalpy value is called thermochemical equation. Say example, if I am just writing 2H2 plus O2 giving 2H2O, this is a balanced chemical equation. We used write hydrogen in the gas, oxygen is a gas, and H2 is a liquid. So this is a normal balanced chemical equation. If I am specifying also what is the enthalpy change for this reaction along with the equation, then the Ender equation is known as thermochemical equation. So a balanced chemical equation along with the delta H value, enthalpy of reaction value, along with the enthalpy of reaction or enthalpy value is known as thermochemical equation. A balanced chemical equation together with the delta H value is known as thermochemical because it's related to showing the thermal energy. As in the normal equation, like normal balanced equation, the coefficients, say example, it means in the case of H2O, 2 moles of hydrogen and 1 mole of oxygen reacts to form 2 moles of H2O. So this number, the coefficient, which we call the coefficients, are related to the moles. Here it is 1. So that is first thing, as in a normal balanced equation. The numbers specify the coefficients in a balanced equation specifies the number of moles. So 2 moles of hydrogen reacts with 1 mole of oxygen to forming 2 moles of H2O. So that is what the importance of coefficient. Secondly, the delta H, that is enthalpy of reactions, will be specified. If it is standard, then it will be in kilojoule per mole. If it is a non-standard, then we used to write kilojoule. Because standard mean we are preparing, either taking 1 mole of a reactant or preparing 1 mole of a product. So it is specified to 1 mole. So the unit will be kilojoule per mole if you are talking about standard enthalpies. Wherever you have standard enthalpy of fusion, standard enthalpy of formation, or you have standard enthalpy of combustion, which we are going to discuss next slide. Anywhere if you get the word standard, then the unit of enthalpy is kilojoule per mole. If it is not standard, then you will get the answer in kilojoule. Okay. So thermochemical equation is a balanced chemical equation along with the enthalpy values. That together they are known as thermochemical equation. And as in the normal balanced equation, this coefficient refers to the number of moles, and enthalpy of reaction, the standard condition, will have the unit of kilojoule per mole. Okay, so please go through the points what we discussed.